do we know for sure about climate change?
Well, I think the evidence is just so overwhelming, and it's not just one line of evidence.
Yeah.
It's the balance of evidence that you always have to look at. But for sure, the Earth is warming. There's no debate on this issue, and the temperatures have risen 0.8 degrees C or 1.4 degrees Fahrenheit since 1900.
Okay.
But at the same time, we see the glaciers are retreating around the world. We have sea ice disappearing in the Arctic. We have temperatures rising in the oceans. We have the sea levels rising. As you melt ice on land, that water goes into the world's oceans. Currently, it's rising at about 3.3 millimeters per year. If you go back to 1900, it was about 0.9 millimeters per year. And as you warm the oceans, they also expand. And so there's a combination of these factors that lead to the increasing rates of sea level rise that we are now monitoring.
What are kind of things are we cannot say, or what is not, the evidence isn't really such that we can say this is definitely attributable to?
I think they're in science. Science is observations, it's projections, testing, and so it's never a straight line. And there are certainly parts of the system that we do not understand well, things like the role of clouds in the climate system, or the full role of water vapor in the system. Water vapor is our most important greenhouse gas.
Yes.
And we don't see it as a driver of climate change.
Good point.
But if you increase other greenhouse gases, you raise the temperature, you increase evaporation, you put more water vapor in the air, you get this positive feedback that causes the temperature to rise even faster. And there seems to be in our system more positive feedbacks than negative feedbacks. And that's certainly one of the things we're concerned about. I mean, even glaciers, you think about ice cover, it's white, it reflects energy. But if you reduce it, what do you expose? Either land that's darker or oceans that are darker. You absorb more radiation coming from the sun. You drive the temperatures higher. This leads to more melting of sea ice or glaciers. And so you get these positive feedbacks.
Oh, yes. I remember reading about the Swiss putting down white sheets to try and maintain the snow that's there.
Well, there's a lot of these things going on, and you have to. I mean, we had an engineer in England who wanted to put tarps over the glaciers on Kilimanjaro.
Oh, yeah.
But people go there. Kilimanjaro is the #1 tourist attraction in Tanzania, and people go there to see the glaciers. They don't go there to see the tarps, and even if it would work, which it wouldn't long term. But in South America, they have people whitewashing the rocks from where the glaciers used to be, and putting sawdust on the glaciers, like in an old ice box, to keep it. But there's no way you do this on large scale.
No, I mean, they've talked about going backwards in my mind of putting sulfates back in the air, like we had the acid rain issue especially in the 70s,
Well, we just had a National Academy report where they're looking at, how about geoengineering? Can we control this? And putting sulfates in the atmosphere? First of all, this becomes very expensive. And it takes a lot of energy to get it up there. And then, yes, we passed the Clean Air Act in 1970 to get the sulfate out of the air so we don't have acid rain. And of course, that's only tackling one part of the issue, because the increasing of carbon dioxide drives the temperature up. But we're also increasing the acidity of the world's oceans, which are impacting corals and these calcium carbonate shells of microorganisms. So if you
which dissolve very nicely, thank you very much, in acid. Yes.
Yeah, and so if you just reduce the temperature, you haven't tackled another very important, and some people believe even more important, issue of how that's going to affect the the basis of the life food source on the planet.
What do you see as good ways for the amelioration or the attention?
Well, I think we have to look at these. I mean, even though I think we have to be extremely cautious about unintended consequences, but things like sequestering, taking it out of the atmosphere, and sequestering it back into the archives where the oil and the gas came from, taking it back out of the system. I mean, we put it in the system, we should be able to take it out of the system. Of course, the question is whether you can do that economically and fast enough to change the trend that we're currently on.
Yes. Well, I saw an interesting comparison that it's $13 a person to address it today versus $125 to address it in 50 years. And we're fooling ourselves if we don't think we are addressing it, building levees and building higher, the infrastructure is.
I think it's cheaper to prepare than to repair.
Yes, exactly.
And that's
good,
really what the options are when you look out into the future. And the sooner we start down this road, the less it'll cost, and the greater the benefit.
Yes, and it's not just one thing, as you say. I remember Sokolov had his 14 fingers of fame. I mean, you have to do so many different things.
Yeah, I think the best I've seen it stated is the fact that, there's no silver bullet to this problem, but there's a lot of silver buckshot. And I think we have that technology. I mean, it's amazing. We built the first solar-powered ice core drill here in this group in 1983.
Oh my!
And we got nothing but negative feedback that this wouldn't work.
Oh, that's great.
But the fact is, if you take a solar panel to 20,000 feet, it actually produces 20 to 30% above manufacturer specs. And so in 1983, we drilled 2 cores to bedrock for a tropical ice cap in the Andes of Peru. It was something people said was impossible. But the thing was, back then, the technology was so archaic, very heavy, and now we have panels that you roll out. They're plastic covered, they're lightweight, and they're 5 times cheaper. And they produce 5 times more energy.
Oh my goodness!
So the technology. I mean, we're making tremendous advances, and we need to do more of that.